Prove that the derivative of a constant function is 0. That is, show that d by dx of c equals 0, where c is a constant. So if we have a constant function, that's going to look like a straight line when you graph it. Something like this. This is f of x equals 2, and you can see it's just a straight line at 2. And the derivative is really another way of asking what's the slope of the tangent line. And I think you can see here that the slope everywhere is going to be 0. So it kind of makes sense that the derivative of a constant should be 0. But in order to prove it, we need to use the limit definition of the derivative because that's how we originally defined derivatives. So what is the limit definition of a derivative? Well, there's a couple different ways to write it, and I'll use this definition. So we have f prime of x, that's for the derivative, equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so a couple things here. This limit definition of a derivative, it's a good idea to know what it is by sort of understanding what it's saying. And you can imagine, I won't do it here, but you can imagine just drawing some generic function, and we have a point x, and then we have another point x plus h, and on the x-axis we have the coordinates x and x plus h. On the y-axis we have the coordinates f of x and f of x plus h, and we're calculating basically the slope of the secant line connecting those 2 points. That's what this expression is here. And then we're letting the limit as h approaches 0 in order to actually get the slope of the tangent line. Okay, so also when we're writing a formal proof, it's probably best to use complete sentences. I'm just going to go ahead and use this expression here to show what we're trying to prove here. Okay, so now we have f of x plus h minus f of x. Well, remember, f of x is a constant, so f of x is going to equal c. And in fact, f of x plus h, that's also going to equal c. Since it's a constant, anything, f of anything is going to equal c. So for this limit definition of the derivative here, this is just going to be the limit as h approaches 0 of c minus c over h. Not very exciting. C minus c, well, that's 0. So this is just going to be the limit as h approaches 0 of 0 over h. Well, 0 over h, as h approaches 0, well, that's just going to be 0. So remember, this is a limit here, so we're not actually plugging in a 0 here for this h. We're looking at what happens as h approaches 0. And since we have 0 over h, the limit as h approaches 0 of 0 over h, that's going to be 0.